Here are some examples and properties of simplifying with radicals. The first property is when you have in power of m, it can also be written like this where it's outside and then the index is still the same, n. The second property is multiplication. Notice they both have to have an index of 2, and then you can multiply these two together into one radical. The third property is division. Notice both of them have an index of n and can be written with division as one radical. The fourth property has an index of n raised to the first power. It can be written as a fraction, a raised to the 1 over n. And our last property is a radical within a radical. You can multiply the two indexes together and convert it to one radical. Remember that you need to know your perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. All the way up to 100. And then perfect cubes, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, and continue on. Here are some examples of simplifying radicals. The first example is the square root of 9. Its index is 2, so you can rewrite that base of 9 as 3 squared. And then notice that the index and the power match up, so your answer is just then 3. This second example, the square root of 16, its index is 2, so you can rewrite that 16 as 4 squared. Now if my index and my power match up, I'm left with just the base of 4. Now notice now we're changing the index in these next two examples to cube roots. So the index now is 3. So if we want to rewrite that 8, we rewrite it as 2 times 2 times 2, which is 2 to the third power. For it to cancel out, the index and the power must match up, so you're left with 2 as your answer. This last example is a cube root. Its index is 3. So to change 27, it would be 3 raised to the third. Again, my index and my power match up, so I'm left with 3. Now let's go on to multiplying. The square root of 8 times the square root of 2. They both have an index of 2, so we can multiply these two together. 8 times 2. And then the index is 2. So you're going to get the square root of 16. If you remember the square root of 16, it is 4. Or rewrite 16 as 4 squared. Index and power match up, so you're left with 4. This example is the cube root of 5 cubed. The index and the power match up, so you're left with the answer of 5. Here's an example of a radical with a fraction. You can separate out that radical into two radicals. Square root of 144 in the numerator, and then the square root of 25 in the denominator. Then the square root of 144 is 12. I'm just going to rewrite it as 12 squared. And then the square root of 25 is 5. I'll just rewrite it as 5 squared. So I'm left with 12 over 5. Example H has a square root of 18. So let's break down 18 as 9 and 3. Then I can break down that 9 as 3 squared. And notice my index is 2. So what I can bring out is the square root of 3 squared is 3. But then I still have this 3 left. So now it is a 3 underneath. The cube root of 24. Let's break down 24 as 8 times 3. And then 8 can be broken down into 2 cubed. And now the cubed root of 2 cubed is 2. And then I still have this 3 left underneath. So then it's cubed root of 3.